What's up, guys? Welcome back to Fantastic Chemistry Podcast. My name is Pete. I'm your host. Tusky is my co-host. He's right behind me. So right there, you see on the board, right there. There we go. Okay, we're on chapter 12. So we got 12, 13, 14, 15. 4 more chapters to go, and we're done. Right? So hang in there. I know it's been rough. But hey, well, it's something you got to do. So you try to pass and try to go get a degree, go to your future career. So it's something that you have to pass through. Okay, but hey, once you get on to the other side, you're stronger. Right? All right. So I believe that you can do it. Okay. All right. So chapter 12. So reaction rate and equilibrium, and you will need the equilibrium for learning in chapter 13, which is the acids and bases. Okay. All right. Let's dig into reaction rate. We're going to start right here with this little guy. So bombardier beetles. Bombardier beetle is a very so it's small but very interesting creatures. Okay, and they got its name from their defensive mechanism. Let's take a look right here. So since these type of beetles are small, so they usually attacked by bug-eating animals like toads or spiders, and etc. Okay, and when it feels under attack, let's take a look. So inside right here, so there are two compartments, two pouches, and this beetle will squeeze these two pouches and mix them together, and then one of these chemicals is actually a very simple chemical, and you guys know it, the hydrogen peroxide, right? Hydrogen peroxide decomposes to water, oxygen gas, and large amount of heat. Okay, this heat is enough to heat up the solution up to 100 degrees Celsius. It's hot. How hot is it? Well, 100 degrees Celsius is boiling water. Whoa! So it looks something like he's shooting a shotgun like that. That's pretty cool, and it's really hot, right? And if you get this like 100 degrees solution on your eyes, oh man, that hurts. Even on your skin, all right. And this a poor toad. Anyway, so this beetle can make this reaction happen in just snap of your hand, so really quick. Okay. However, the rate of the decomposition of hydrogen peroxide is known to be slow. How slow? Well, if you go to buy, let's say, a solution of hydrogen peroxide from a drugstore, from a grocery store, you open the cap, you have about 30 days to use at its peak of its effectiveness. Okay, at the peak of effectiveness. 6 months later, there's no use. All hydrogen peroxide get converted to water and oxygen gas. So my point is, this reaction is really slow. Hey, hold on though. How come? This beetle can make this reaction happen in just a split second. Well, spoiler alert. So there's a compartment right here, the white one, where enzyme is stored. And enzyme, what does enzyme do? I think some of you know. So it catalyzes reaction, speed up the reaction, make this reaction go much more quickly. Right, so hydrogen peroxide decomposes to the product in less than 1 second, so instantly, basically. That's why the bombardier beetles can shoot this hot solution right in whenever they want to. Okay, the same reaction but different catalyst. So hydrogen peroxide decomposes into water vapor and oxygen gas, and the build up pressure into in the tank propel a person to the air. So we use it in the what do you call it? Like a skyrocket. I don't know what they call it. Anyway, okay. So the gazillion reaction in this world, some of them are known to be really quick, and we've seen this together. So a precipitation reaction at barium ion and sulfate ion. When it comes to contact, they precipitate right away. Just quick, just snap your hand. All right. Some reaction takes longer. For example, the digestion of your food and metabolism. Taking medicine and eating food. And this give is when a baby, someone feed baby a medicine, and clearly she doesn't like it. Other reaction is really slow. For example, the hydration of calcium silicate, or the hardening of concrete. Okay, so making cement or concrete takes time, could be years. And maybe we also have some reaction that really slow. We have like formation of fossil fuel to make oil, or and all the fossil fuel takes I don't know 1,000 years, million years, I don't know, it's how long. Okay, it's really long. Okay, so why do we study how fast reaction proceeds? Okay, we talk about the rate of reaction. Why do we study the rate of reaction? Well, there are multiple applications. I'll give you some example right here. I'm sure you have learned this in middle school, high school. I'm not going to get into the detail. The ozone layer. Study the rate of reaction can tell you how fast the ozone is depleting. Okay, how quickly these toxic gases destroy ozone. We can tell you that. Study the rate of reaction can tell you. So I'm sure most of us have taken ibuprofen before. So it's an NSAID drug. So pain relief, fever relief. Study the rate of reaction can tell you how long does it take for ibuprofen to take an effect. Like when you eat, how long does it take for you to feel something? Okay. By the way, so in about 12 minutes, depends on the person, but usually about 12 to 14 minutes after you take the medicine and you feel the effect of ibuprofen and circulate in your blood. Take some time. Okay. Study the rate of reaction. We know this too. Are you familiar with CBD oil, CBD water? Really popular nowadays. Okay, because weed usually not popular, but this guy is the relieve. What's it called? So let me read real quick. So. Relieve chronic pain, reduce anxiety and inflammation. Okay, but the CBD is not psychoactive. Doesn't make people get crazy like its brother THC. And THC is a substance that students usually take when they have a lot of chemistry exam. So, right, study the rate of reaction can tell you why this guy is psychoactive, not psychoactive like THC is. Okay, so these are application of it. So. Here's the important point of study the rate of reaction. So first of all, how fast, the speed, and the rate of reaction. What control, the factor that influence the rate of reaction, and what change, the changes the molecules during the reaction. The study of this we call chemical kinetics, which is the study of the speed and the rate of reaction. Okay, all right, quite a fun introduction. Now let's get into the detail.